Hello students, how are you? Myself Jamin Patel. I'm going to take your science subject. Now, today we will start with the chemistry parts. In chemistry, first chapter, that is the chemical reaction and equations. So students, you are familiar with these terms, chemical reactions and chemical equations. Now, what is the meaning of chemical reactions? Okay, if you want to define the process, then what is the meaning of chemical reactions? So in simple sense we can say is that if the nature and identity if the nature and identity of the initial substance are changed, then we can say is that chemical reaction is occur. Some of the example is there. One simple example, okay, if we place the milk in summer season whole day outside the fridge, so definitely we observe that the milk is converted into the curd. So it is a chemical reaction. Why? Because the component present in the milk is going to change. Lactose that is present in milk is converted into the lactic acid. In the same way, suppose if I talk about the corrosions of the iron. So iron is the Fe form. Now it is converted into the oxide of Fe. It is converted into oxide of Fe. So it is also chemically changed. So if the nature and identity of initial substance is going to change, then we can say is that the chemical reaction is occur. In the same way, if I talk about the digestions of the food, so we know that in food we take the complex carbohydrate. This complex carbohydrate is digested by the different enzymes present in our body and is converted into the simple carbohydrate, that is nothing but the glucose. Okay, so it is also one type of chemical reaction. So in simple sense we can say is that if nature and identity of initial substance are changed, then we can say is that chemical reaction is occur. Okay, students, you already study in 9th standard, that is two type of changes, the physical change and chemical change. What is the meaning of physical change? Physical change means if the substance character physically is going to change, means suppose for example water. So ice is converted into the liquid water is converted into the vapors. So here state, physical state is going to change, but the property, chemical formula, chemical structure of the water that remains same. So here it is not considered as a chemical reaction, it is only physical change. So when the chemical changes occur, whenever the chemical change occur, we can say the chemical reactions has taken place, otherwise not. Physical change, by the physical change we cannot say that here the chemical reaction is occur. Here how to judge, suppose for example some changes occur, and how to judge here this change is chemical change or it is a physical change. So here we will understand some of the activities. These activities can give the idea about predictions whether chemical reaction occur or not. One common activity is there, that is the burning of magnesium ribbon. So here what to do in this activity? So it is very simple activity. In this activity we should take one magnesium ribbon, this magnesium strip, in simple sense we can say that magnesium strip. This magnesium strip should be rubbed with the sandpaper. The purpose is to remove the thin oxide layer present on the surface of the magnesium ribbon. This thin oxide layer of the magnesium, this oxide layer itself of the magnesium oxide layer is present on the surface of the magnesium ribbon. So this thin oxide layer retard the burning process of the magnesium ribbon. So to facilitate the burning of the magnesium ribbon, there is need to remove that oxide layer. So that's why magnesium ribbon should be rubbed with the sandpaper. Later on this magnesium ribbon should be taken by the pair of tongues. Later on this magnesium ribbon should be placed over the burner. So we observe that the magnesium burn with dazzling white flame. Magnesium burn with the dazzling white flame, and the white powder is produced. Okay, it is converted into the white powder, and that white powder is collected in watch glass. So that white powder is magnesium oxide. So we can say is that the reactions of magnesium occur with the environmental oxygen when the burning process is occur. Burning process is nothing but the one type of oxidation process that we will study later on. So when the burning process is occur, on that time the component means that chemical is react with the environmental oxygen and produce the oxide compound. So here also the magnesium is react with the oxygen and produce magnesium oxide. So here from this activity one prediction is done, that is if the color is going to change, white powder is produced. If the color of substance is going to change, then we can say chemical reaction is occur. One more activity is given here, that is mixing of zinc granules with the concentrated acid. So see student, here we should take one conical flask. Now in this conical flask we should pour we should place the zinc granules. Okay, later on close the conical flask with the cork, and through the Thustal funnel we will add the concentrated HCl, otherwise concentrated sulfuric acid. Any concentrated acid can be used, means hydrochloric acid, otherwise sulfuric acid. Any concentrated acid can be used. So this acid is mixed with the zinc granules. Now the reactions between zinc and this acid is occur. Okay, and it will evolve the gas. Okay, gas is going to produce. So here if productions of gas is occur, then we can predict some chemical reaction is occur. Here actually when both the component is going to mix, means zinc and acid is going to mix. Okay, how we can predict, from which observations we predict here chemical reaction occur or not? So simple observation is that is the productions of the gas. So this one is the second observation. If the gas is going to produce, if the effervescence is going to produce, it indicates that two chemical is going to react with each other and produce the new component. So here we can predict a chemical reaction is occur. Third reaction is that, third example, third activity is that mixing of lead nitrate solution with the potassium iodide solution in test tube. When we mix this both the component with each other, again here the colored fume is going to produce, colored gas is going to produce. So from this all the activities, okay, we receive some of the observations, and these observations can predict, from these observations we can predict whether chemical reaction is occur or not. Okay, so when any chemical reaction is occur, some changes occur in the process, during the process. So suppose for example if the state is going to change, in some of the cases state is going to change, the chemical reaction is occur. Color is going to change, white color powder is produced. Evolutions of the gas, if the gas is going to produce. Change in temperature in some of the reactions. Suppose for example, okay, if I use the glass of water and if I add the few drops of concentrated any acid, and if I kept the glass, means if I touch the glass from outer surface, so definitely the temperature of the glass is going to increase. It indicates that here the reaction between acid and water is occur, and the temperature is going to increase. So different reaction is there in which the temperature is going to change. It indicates that the chemical reaction occur. Okay, so here these are the some parameters, otherwise some observations. From these observations we can predict whether chemical reactions occur or not. Okay, now here we discussed about the chemical reaction. Now scientists thought that how to represent the chemical reactions. Suppose any chemical reaction is occur, so whether the chemical reaction should be explained in form of the sentence only. Okay, in past, if you talk about the ancient time, in past the chemical reactions was described in form of sentence only, and it is quite long and it is tedious. Okay, suppose for example if I talk about the first activity, So when the magnesium, okay, representations of these chemical reactions, when the magnesium ribbon is burnt in oxygen, it gets converted into the magnesium oxide. So this is the representations, okay. So representations of the chemical reaction in form of sentence. So it is quite tedious and long. Suppose for example, if you want to study the 20 to 25 reaction and every reaction is written in form of sentence, so it is very tedious job to read all the sentence and to understand all the chemical reaction. So that's why scientists thought that, can we represent this chemical reactions in shorter way, in simple way. So later on scientists introduced the new concept, that is the word equation. Word equation means here chemical reactions is represented in form of word equations, okay. Suppose magnesium, if you talk about here, every time we will discuss about the activity 1. So here magnesium is going to react with the oxygen and produce the magnesium oxide. The same things, okay, here written, it no sentence, no other component is involved. Simply we write the magnesium plus oxygen, it gives the magnesium oxide. So reactant means the substance that undergo the reaction, that undergo the chemical change, is called as a reactant. So reactant should be right on left hand side of the arrow. Reactant should be right on left hand side of the arrow. Reactants should be right on left hand side of the arrow. If the reactant is more than 1, then it is represented by putting the plus sign between them, okay, plus sign between them, okay. If the reactant is more than 1, then we should place the plus sign between all the reactants, and later on we will show the arrow, okay. So in left hand side of the arrow reactant is there, in right side and right hand side of the arrow is product is there. Product means on right hand side, again the same principle, same rules. If the product is more than 1, then we should place the plus sign between them. Here only one product is there, that's why the plus sign is not involved here. But if the product is more than 1, then definitely there is need to place the plus sign. Now new substance produced during the reaction, that new substance should be called as a product. So here it is the simple representations, magnesium plus oxygen, magnesium plus oxygen gives the magnesium oxide, okay. If we write in this way, so definitely simple chemist can easily understand this reaction is like this component, this reactant is involved in the reaction, and this product is produced in the reaction. So it is very simple representation. Now later on again scientists were not satisfied, they tried to represent this chemical reactions in concise form and in informative way, okay. Here again if we write the name, so suppose for example if 3 to 4 reactant is involved in the reactions and 3 to 4 product is produced in the reaction, so definitely it is long reaction, okay. If 3 to 4 reactant is involved in the reaction and 3 to 4 product is produced in the reaction, so if we write this all the name, okay, long name, suppose the sulfuric acid is there, hydrochloric acid is there, sodium chloride is there, so again this whole chemical reaction take 2 to 3 lines. So again scientists thought that, can we represent this chemical reaction, means this chemical reaction, this word equation in shorter way or in more informative way. So they introduced the new concept, can we use chemical formula instead of the word, okay. So they introduced the new concept, use of chemical formula instead of the word, use of chemical formula instead of word. So here the same reaction is there, see here the reactions take this long space, okay, but here the same reactions is completed in short space. So simple, Mg plus O2 gives the Mgu. We should know the chemical formula of reactant and product. that involve and produce in the reaction. This chemical reaction, sorry, this chemical equation should be called as a skeletal chemical equation. It should be called as a skeletal chemical equation. Now here we observe that the number of atom in this equation is not in balanced form. If the chemical reaction is in unbalanced form, then it is called as a skeletal chemical equation. If the chemical equation is not, means atoms in both the side is not in balanced form, is just a draft chemical reaction, then this type of chemical reaction should be called as a skeletal chemical equation. It just gives the idea which reactant involved in the reaction and which product produced in the reaction. Okay, but again there is need to balance the chemical equation. Why? Because in 9th standard we already discussed the law of conservation of mass. We already discussed the law of conservation of mass, and according to law of conservation of mass, mass can neither be created nor be destroyed in any chemical reaction. So mass should remain constant, and according to Dalton's theory, all the atoms possess the same mass. Mass is not going to change. Suppose the sodium is there, that mass is 23 AMU, so it remains 23 AMU, is not going to change in any chemical reaction. So atom mass is constant, and mass in any chemical reaction is constant. So definitely atom number should remain constant. In any chemical reaction, atom number of atoms should remain constant. Number of atoms, okay, here बाहर चला गया, number of atoms should remain constant. So here in any chemical reaction, number of atoms from on both the sides should remain same, right? Now here it means skeletal chemical equation should converted into the balanced chemical equation, right? Suppose some of the activity is there. Suppose if I talk about the activity 2, zinc granules come in contact with the hydrochloric acid, otherwise the sulfuric acid, and it produce some product. So some of the chemical equations, suppose for example here zinc is react with H2SO4, it produce the zinc sulfate plus H2, right? This is the one chemical equation is that, right? This is one chemical equation is the right. Now in this chemical equation, see the number of atom on both the side is same. See zinc 1 on right hand side, zinc 1, hydrogen on left hand side 2, hydrogen on right hand side 2, sulfur on left hand side 1, sulfur on right hand side 1, oxygen on left hand side 4, oxygen on right hand side 4. So number of atom on both the side is same. So this skeletal chemical equation itself become balanced chemical equation. This type of reaction, there is no need to balance the chemical equation. Okay, if the reaction is not in balanced form, then only we should go for the balancing purpose. Here one example, one chemical equation is taken as a sample chemical equation for balancing. How to balance the chemical equation? So here different step is there to balance the chemical equation. Now first step for balancing, that is whatever the chemical formula is there, that chemical formula should remain as such. We cannot change anything inside the chemical formula, and that's why first step is to make the box. First step is to make the box surrounding to the chemical formula. Okay, yes, the simple purpose is there. Step 1 means the simple sense is there. It just gives the idea whatever the chemical formula, that chemical formula should remain same. we cannot alter anything inside the chemical formula. Suppose here, see here H2O is there, sorry, here H2O is there, so we cannot write the H2O2 for balancing purpose. We cannot write the H2O2 for the balancing purpose. Okay, H2O should remain H2O. Fe3O4 is there, so it should remain Fe3O4. We cannot write the Fe2O3, otherwise the Fe3O5, otherwise Fe3O3. Okay, chemical formula should remain same. So that's why just first indication is there. In step 1, only indication is there. Formula, whatever the chemical formula is there, that formula should not change. That formula should remain same, and that's why the simple word is used, make the box around the each formula. Okay, now second step in this balancing process, that is the provide the number of all the atom involved in the reaction and produced in the reaction, means the number of atom in left hand side and number of atom in right hand side. Number of atom in left hand side and number of atom in right hand side in reactant and in product. Okay, now here only 3 atom is involved. One is Fe, second one is the hydrogen, and third one is the O. So Fe number on left hand side is 1, on right hand side is 3, hydrogen on left hand side is 2, on right hand side is again 2, oxygen on left hand side is 1, on right hand side is 4. Okay, so here the number is identified. Now our purpose, our main intentions in balancing the chemical equation, that is to make the equal number on both the side in LHS and in RHS. So now from step 3 we will start the balancing process. Now here for balancing, which element should be in first priority? So it is trial and error based process, but yet in our syllabus in CBSE the rules is given, if the number of atom we should start the balancing with the atom having a maximum number. We should start the balancing of atom having a maximum number in LHS or in RHS. So here see which atom having a maximum number. Oxygen having a maximum number, oxygen having a maximum number, that is the 4. So we should start the balancing with the oxygen. We should start the balancing with the oxygen. So here see oxygen in left hand side is only 1, while in right hand side is the 4. So we should make the 4 oxygen in left hand side. So that's why we cannot write, we already discussed, we cannot write the H2O4. Okay, why? Because we cannot alter the chemical formula of any compound. Okay, so here just a minute. Okay, we cannot alter the chemical formula of any compounds, any reactant. So here this H2O should be multiplied with the 4. So for that purpose, in this equation we will multiply the H2O with the 4. So simple, these equations, in these equations we will multiply the H2O with the 4. So H2O is multiplied with the 4 for the balancing purpose. So new equation is generated, that is Fe plus 4H2O gives the Fe3O4 plus H2. Now here, now oxygen is in balance form. Oxygen is in balance form. This one is again the partially balanced equation. Now we should again find the number on both the side. So if I talk about the Fe, if I talk about the hydrogen, if I talk about the oxygen, so in LHS and in RHS, So number of Fe in LHS is 1, in RHS is 3, hydrogen is now it is 8 in left hand side. See here, 4 to ja 8, and right hand side is 2. Here oxygen in left hand side is now become 4, and right hand side is 4. So now oxygen is balanced. Now our intention is, means our next target is to start the balancing of the atom, another atom. So here we will start the balancing of the hydrogen. We will start the balancing of the hydrogen. So here what to do? Here already in left hand side 8 hydrogen is there. So in right hand side there is need to make the 8. For that purpose simple way is that we will multiply the H2 with the 4. We will multiply the H2 with 4 to make the 8 hydrogen in right hand side. So equation is become Fe plus 4H2 gives the Fe3O4 plus 4H2. Now again this one is the partially balanced equation. Again same process is there, same repetition is there. We will make, means we will count the number on both the side. Fe in LHS, in RHS. LHS and RHS. In LHS Fe is 1, in RHS Fe is 3, hydrogen is 8, hydrogen is 8, oxygen is 4, oxygen is 4. See here, this both the atom is already in balance form. Now only one atom is required to be balanced, that is the Fe. So here in right hand side Fe is 3, while in left hand side Fe is only 1. So simply multiply the Fe with the 3 and make the balance equation. So here simple Fe should be multiplied with the 3. So here this equation is from 3Fe plus 4H2O gives the Fe3O4 plus 4H2. So this one is the balanced chemical equation. Now the next step is to remove the box from the formula. So 3Fe plus 4H2O gives the Fe3O4 plus 4H2. So now calculate the number again just for the cross checking. Here 3Fe, 3Fe, 8H2, 8H2, 4O, 4O. So now this equation is in balanced form. So by this way we can prepare the balanced chemical equation. Okay, so in simple set it is heat and trial method. Okay, in this equation, in this equations we in this equations we can balance, means in this way we can balance the chemical equations, right? Now scientist yet not satisfied, whatever the balanced chemical equation is become, means is formed, later on scientists thought that okay, this equation should be more informative, some more things should be included in this equation. Okay, so here they thought that here whatever the chemical involved in the reaction, that chemical is in which state, that should be reflected in the chemical equation. When any chemical reaction is occurred, so some reactant is involved in the reaction, some product is formed in the reaction, this reactant is involved in which physical state, this product is formed in which physical state, this should be reflected, this physical state should be reflected in chemical equation. So that's why scientists introduced the new concept. They are introduced, scientists introduce, just a minute. Okay, now scientists introduce the new parameter, that is new notation, that is a G, L, A, Q and S. What it means? Suppose if the reactant or product involved in the reaction is in the gaseous state, then we should write the G. If that reactant or product is in the liquid state, then we should write the L. If the reactant or product is dissolved in water and we make the aqueous solution, and that aqueous solution is utilized for the reaction, otherwise this aqueous solution is formed in the reaction, then we should write the AQ, aqueous. And if the reactant or product involved in the reactions or produced in the reaction is in solid form, then we should write the S. This notation should be placed right side subscript of any chemical formula. We should write this notation at right side subscript to any chemical formula. Okay, so G for gaseous, L for liquid, AQ for aqueous and S for solid. Okay, here simply see here 3Fe. Okay, here we discuss about the previous equation, that is 3Fe. Here bracket S is written, means Fe is involved in this reaction in solid form. For H2O, we know that the H2O is in the liquid form, yet here the G is written. What it means? It means that here H2O is used in form of vapor, in form of steam, not in form of liquid. Why? Because we know that the liquid H2O is not capable to react with the Fe quickly. So steam is required for the reactions with the Fe, and that's why here we use the steam. Here the H2O is involved in the reaction, but this H2O is in form of steam, in form of vapor. Then only it can react with the Fe and can produce the Fe3O4. Whatever the Fe3O4 is produced, that Fe3O4 is solid in state, and side by side 4H2 gas is produced. This 4H2 is in the gaseous form. So by this way we can represent the physical state in chemical equation, right? Generally in all the cases the physical state is not included. Okay, usually physical state are not included in chemical equation unless it is necessary to specify them. Okay, in normal equation the physical state is not going to include. So by this way we can make this chemical equation more informative, yet scientists are not satisfied. Scientists thought that can we make this chemical equation more informative, means whatever the parameter is required, means whatever the condition is required to perform this chemical equation, that condition should be reflected in this chemical equation. Okay, so here simply suppose some reactions is occur at 100 degrees Celsius only, some reaction is occur at 100 Pascal pressure only, some reactions that occur in the presence of some agent only. So this agent, it facilitates the reactions, some temperature condition is required for the reaction, some pressure condition is required for the reaction. This all the parameter, this all the condition that is compulsory required for fulfill the reaction, it should be reflected. So where should be right? So it should be right above or below, it should be right above or below the arrow. Okay, whatever the parameter, means whatever the reaction condition is there, that reaction condition should be right above or below the arrow. Okay, suppose here carbon monoxide react with the hydrogen gas, sorry, and produce the methanol. So here carbon monoxide is in the gaseous form, hydrogen is in the gaseous form. This both the gas not directly react with each other, it can react only when the pressure is 340 atmospheric pressure. When the pressure is 340 atmosphere, means very large pressure is created, then only this both the gases react with each other and produce the methanol. Okay, here one another example is that carbon dioxide is react with the water molecule and to produce the glucose, oxygen and water molecule. So this one is simply the reaction of photosynthesis. Plants can produce the glucose and oxygen in presence of sunlight. So the same process is there, means that photosynthesis process is there, but it is occur in presence of sunlight only. It is occur inside in presence of chlorophyll only. So these are the reaction condition. This reaction conditions is compulsorily required for completing this reaction. If I talk about the another example, whatever the complex carbohydrate that we take in our daily food, this complex carbohydrate is digested by enzymes present inside the body, present in GI tract, present in digestive tract. So this enzyme will digest this complex carbohydrate and convert into the simple carbohydrate. So here that enzymes involved in this process, so that enzyme should be right above or below the arrow. This enzyme should be right above or below the arrow. So here any reaction conditions that required for completing that reaction, it should be written above or below the arrow. Then this chemical equation is become a complete chemical equation. Understand? I think so. You are you well know how to balance the chemical equation, right? In our next lecture, we will take some of the example for balancing purpose. We will take some of the chemical equations for balancing, and we will make the practice in our next lecture. Thank you very much.